This problem says for the following exercises, draw an outline of the solid and find the volume using the slicing method. The base is a triangle with vertices 0, 0, 1, 0, 0, 1. Slices perpendicular to the x-axis are semicircles. So we can draw a graph of what this looks like. We have a vertice at 0, 1, 1, 0 I mean, 1, 0, then we have one at 0, 1, and we have another at 0, 0. We can connect this and we'll get a line. And we should probably find what the equation of this line is equal to. Because the slope is equal to -1, we can see that as the y changes by -1 value, the x goes across 1. So we can see that the slope is -1, negative x plus the y-intercept is 0, 1 right there. So we can get plus 1. So we get y is equal to negative x plus 1. Because this slices perpendicular to the x-axis, we will need to use the equation. The volume is equal to the integral from a to b of the area function of x dx. So the area function is equal to 1/2 pi r squared because we're looking at semicircles. That's the equation for semicircles. We can see that the radius, the side will be equal to this, but that's more like the diameter. So to find the radius, we'll need to do 1/2 the diameter, which means area is equal to 1/2 pi diameter over 2 squared. We can factor out the 2 by squaring it. We can say area is equal to 1/2 times 1/2 squared, which is equal to 1/4 times pi d squared. You can also think of d as equal to the y value at the certain function. So we can replace d for y. We can say area is equal to 1/8 pi y squared. Then, because we have our equation y equals negative x plus 1, we can now plug that in to get area of x in terms of x. So we can set this equal to area is equal to 1/8 pi times negative x plus 1, negative x plus 1 squared. Negative x plus 1 squared is equal to, we can factor this out, negative x plus 1. We can multiply negative x times negative x to get x squared minus 2x plus 1. So let's clear some room for this. So the next step in this process is to start plugging the values in. Basically, because it's from 0 right here to 1, it'll be the integral of 0 to 1 of a of x, which we now know is 1/8 pi times x squared minus 2x plus 1. The value we got from this. And then now we can plug in the dx from here into this. We can factor out 1/8 pi from the equation to get the integral of 0 to 1 of x squared minus 2x plus 1 dx. Now we can solve this. We'll do 1/8 pi times the value of, we'll find the integral. We'll do x cubed divided by 3 minus x squared plus x from the value 0 to 1. Evaluated the value 0 to 1. Then we can evaluate this and we'll do 1/8 pi is equal to, we'll evaluate at 1 and we'll get 1 cubed is 1 divided by 3 is 1/3 minus 1 squared is 1 plus x is plus, that's basically plus 1, so plus 1, and then minus 0. As we can see, it's just going to evaluate to 0 because x cubed is equal to 0, x squared is equal to 0, and x is equal to 0. So minus 0, and then we'll simplify this. We get 1/8 pi times 1/3 because -1 plus 1 cancel out. We simplify this and we get 1/24 times pi, which is equal to pi over 24, and that is our answer.